Here-ish. Whoops. Like here-ish. I don't know.
Here-ish.
I think we kind of, this is, now, in asking you open question, what do you think, Mars? Have there been spacecraft visiting Mars? And yep. There's one kind of recently, Curiosity, and it's like, I have a t-shirt that says, have you satisfied your curiosity? And it has a picture of Mars, has a little rover on it. So Curiosity is one of the little many rovers. And so again, when you're looking at Mars, these are pictures taken of Mars. So what did we say? This is looking down at the NP stands for North Pole. Okay, so there is ice up there, but it's probably not water. What did I say it probably is? Yeah, carbon dioxide, dry ice, CO2S, meaning solid. Yep. So speaking of CO2 solid, now this actually was taken by the this cute little Phoenix lander dug a little trench, and it hit the CO2 solid down here. And this is taken 4 days apart, and if you compare this region, okay, you can see that those little white chunks have gone away, and it's quite like what you get at Hy-Vee. If you've ever gotten dry ice at Hy-Vee, it's solid CO2, and the word is sublimes. It goes straight from a CO2 solid to CO2. I'll put a G here. What does that G stand for? Gas. Yep. That's called sublimation, when something goes from a solid directly to a gas, gives the liquid state.
So how far did they have to dig down?
Well, it's kind of giving us a scale.
Or is
One,
it just like
a little less than an inch is, so it's not very far down. Yeah. The video we watched on Monday said, do you remember what makes the soil red? Iron. Very good. Iron oxide. Perfect. So again, some surface pictures of Mars. Now, water doesn't flow there now, but there are definitely features on the surface of Mars that suggest that water used to flow freely. Okay, so you can almost kind of see the little tributaries. Yep, like that. Of course, you see the impact craters too. And you can definitely see or imagine, water flowing there to make that erosive pattern on the surface. So why are we so concerned or curious about water flowing? Who cares? Is that what we could live? Life, yes. Something could live there if water flows, as far as life as we know it. Now, if we've watched a few videos called, and they've referred to extremophiles. Extremophiles are, phile means to maybe life, and extreme means extreme. So extremophiles are usually little organisms that can live in extreme conditions. So, but anyway, yeah, we're looking for liquid water because we're curious about life. So this is kind of showing you some maybe streaks of where water can or does flow down in its liquid state. This is kind of another photo of the surface of Mars. If you read it, I thought this was kind of weird. I'm like, it looks weird, but it's kind of fluffed up. And again, trying to show you, you see these dark streaks right here? And as I understand it, what they've done is, you've got rovers all over the planet. Well, not all over the planet, but rovers have actually they'll capture an image and they'll look at it later, and the streaks have changed. So it's something dynamic, which is good. Looks like Earth, I think. And this is a close-up of, so this is Mars, okay, taken by Curiosity. Have you satisfied your curiosity today? And this is a close-up of, you can kind of see the striations of the sedimentary rock. It's just so cool. But what's its atmosphere like, do you remember? Carbon dioxide, yep. Carbon dioxide, and it's thinner. The video talked about historically that You know, the cool thing about science is it evolves. Goodness, gravitational waves. It's been in the news recently about people getting was it a Nobel Prize for gravitational waves?
You see the eyes and the teeth?
So this is eyes, and these are the teeth.
Yeah.
I see the pumpkin thing going on there. But this is what they a picture of what somebody drew, seeing surface features of Mars. Now, one of the things we saw in the video is that Mars has these dust storms. We even saw a picture of a dust devil, didn't we? Has these dust storms that probably kind of create some of these features that's actually seasonal. But pretty cool. This was back in I don't know if this would have been 1659 or 1877. I don't know, a long time ago. So in 1877, though, Schiaparelli actually called these, I've heard two different things. I think he's Italian, right? And he called these canali, which kind of mean like tributaries, like Mother Nature makes like flowing water sort of things. And then that got translated as to like the Panama Canal, like something that a human would make for intelligent life. So then, of course, we enter into kind of, and the video kind of talked about this. Remember the video had a picture of the funny little Martian? Yeah. So, Mars, yes. So people's imagination kind of did their thing. Now, back in 1938, radio was quite the wave. Okay, 1938 did not have television. And so there was a radio series where they would, actors would come in and play out a story, and then people would listen to it at home. And so there's Orson Welles is the person who did the story, and the book was written by H.G. Wells. Now, am I the only one that kind of drives you nuts? The Wells and the Wells. But anyway. So before they did, H.G. Wells wrote this book about Martians coming down to Earth. You know, it's a sci-fi book. And then Orson Welles said, well, let's do a play about it. So before the play started, they announced, they said, well, welcome to the theater, and this is just a play. And then they proceeded to do the H.G. Wells' book. And H.G. Wells' book and told the story of basically Martians landing on our planet in the New York area, I think, and people would tune into what was a theater story and think it was a live story. So 1938, and I think it didn't help that it was creepy on Halloween.
A lot of mass suicides.
Okay, I knew there was chaos, and Gary says.
It affected Orson Welles for the rest of his life because of all the traumatic events that happened from that. Right. Even though that they they prefaced it. They did broadcast and say it every so bright, saying, "Hey, this is just a play. Yeah. This is just a play."
I listened to what I think is the original broadcast. So if you ever get a chance, 1938, it's out there on YouTube, and it's well done. You know, the actors do the whole thing, and it definitely affected people adversely. I thought about that though, because that's like I don't know. And then I brought in this. I don't know if this is a picture of, but they've done some really good. There was another one, War of the Worlds, is the title of the story, and they did a movie about it. It was pretty good. So anyway, Mars. This is one of my. I think this is really neat. Can you see the man up here? Yeah. And so in the, I want to say early 70s, early to mid 70s, a flyby by the Viking mission captured that image. And wouldn't that make you go, wow? But later on, the same region looks like this, which, I don't know, still looks like. But you figure, we just talked about dust storms, you know, and wind blowing and I think they call it regolith too. We call it regolith on the moon's surface, and that powdery stuff is also regolith here. But anyway, so the point here is no, there's no artistic structure. Mars. I think we looked at this before. There's different ways to get that. You see this cute little rover? I think we said about the size of a microwave. Okay, there's different ways to get that thing safely on the planet. But here was the package that unfolded, and then the little thing called All right, so yes, you said carbon dioxide. It's mostly carbon dioxide, and what the air we're breathing is mostly nitrogen. Yep. So mostly carbon dioxide. It does have some water, but it's just a little bit. And you guys told me iron. Okay, if I ask you on a test, you'd say iron, or you could say iron oxide, the same thing as what makes it red. That when I say it, I mean the surface. Cool. So this again is looking down at the North Pole, or a pole, assume it's the North Pole. Is Mars' axis of rotation tilted? Yes. How much is Earth's axis of rotation tilted? 23.5. And this one's a little bit more than that, 25. So as it orbits the sun, it keeps that same tilt. And so that carbon dioxide up here, this dry ice, actually in wintertime, it will ice over, and in summertime, it will sublime. Okay, so you kind of see those poles kind of doing their thing. How would you compare the amount of time it takes it's on this slide, the amount of time it takes the Mars to go around the sun once to the amount of time it takes the Earth to go around the sun once? About twice as long, yep. 365 versus 687. Now, they're called configurations. It's kind of configuration in astronomy just simply means kind of where is the sun and the planets, where are they at? So if that's the sun and I am Earth, and of course Mars is outside of the Earth, about every 2 years we kind of catch up with each other. I guess the Earth catches up with Mars. Mars is going like this and the Earth is kind of going like this. Okay? So about every 2 years our configuration kind of lines up. So about every 2 years, that's when you'll see NASA look at the logistics and try to get something to Mars. So about every 2 years. All right. So this is kind of a dust devil in motion, and it's creating those dark streaks on the surface of Mars. Martian moon, anybody? Yep. They're called fear and panic. Phobos and Deimos. Do they look like Earth's moons? So I think the video talked about this. They're thinking that it looks actually just like an asteroid. So it's quite possible that an asteroid just got too close to Mars and has been orbiting ever since. But did you hear the video? I guess I hadn't realized this. What did it say about one of the moons? It's getting closer and closer to the planet Mars. One of the moons, and then it's called, and you'll hear this in sci-fi movies, once that moon gets too close to the planet, the gravity, or maybe it's the atmosphere, but it will basically sort of kind of bust up. It'll either bust up or based on its trajectory, it'll fall through, but probably bust up and make, what will happen then? Make rings. Like how cool is that? So I told you I had this, and this is just a website. I'll post this on Twitter. But I told you Mars is a very busy place. And I think the website I chose is just a NASA website. You might have heard of ESA. So of course NASA is our space agency. ESA stands for the European Space Agency. And I know there's other space agencies out there. But check this out. Missions to Mars. Ooh, active, future, past. You can click on these and know. I mentioned Curiosity. Let's see, Opportunity. And which starts letter S, which one did I say died? Solar panels. What's that? It's Spirit. Yes, it is Spirit. So those were kind of sisters. Opportunity and Spirit kind of landed about the same time. Opportunity is still going. What a rush, though. You think those NASA people just kind of like remotely running their little rovers. Gosh. So anyway, I'll just kind of leave this to you. But these are all our missions, and there are definitely other missions.
So Opportunity and Spirit were both rovers too? Yeah.
Opportunity, Spirit were kind of within, I think, the same kind of 2-year cycle, within maybe a few months of each other. Yep. So they're similar. And on anybody in here seen that movie, The Martian? It's good. He goes out and he finds a rover or something, but he revives a NASA spacecraft. So that's so cool. Anyway, and if you went to see Dr. Green talk, he was the consultant for that movie. Okay, so this kind of summarizes, starts with the letter T. What do we collectively call these inner planets? Terrestrials, yep. Very good. So I kind of have some columns. It's hard to read, but here we have from the order of the sun outward, and that might be a test question, who knows? Okay, we have Mercury, Venus, Earth, Mars. What are their surfaces like? And I think that, just because I can, I think on your test on the 18th, I'm going to actually have like a picture show playing up here, and where I'm going to show an image of each of the 8 planets. So you have to tell me which planet it is. Okay, so it'd be like a fill in the blank. I think that would be fun. I've done that before. What they kind of generally look like, their surfaces. How hot are they? Which one's the hottest? Yeah, Venus. It's hard to tell, but Venus is 750 Kelvin. Why is Venus so hot? Greenhouse effect. All right. Atmosphere. Who has the thickest atmosphere?
Probably still Venus.
Probably Venus. I don't like Venus. Yep. Venus. Okay. So let's go on. Starts the letter. Well, let's talk about these planets. You can call them different names. What do you call them? Gas giants. I'm liking that. Gas giants, Jovians, same thing. All right. And their moons. Do the gas giants have moons?
Yes.
Yes. How did they get their moons?
Sucked in by gravitational.
Well, some of them may. I think, though, also, remember we saw that picture with, I'll go out here. So here's my asteroid belt, and here's Jupiter. We saw that picture of when the sun was forming. Big old Jupiter was also forming, and it had its own kind of little disk of material. So actually, within that disk, starts letter A. What do plants do? Is they get bigger, they get snowball and get bigger. Accretion. Yeah, accretion. I always think of like accretion formula. It's like a, anyway. So we call it accretion, and kind of this little skirt of material around Jupiter actually kind of snowballed and formed some of the awesome Jupiter moons. But I think also gravity can kind of pull in an object, just like we saw with Mars, Phobos, and Venus. So yeah, let's take a few minutes. I think it's only 10 minutes long, 8 minutes. Let's look at this little video, and well, we'll watch it if we have sound, which I hope we do. That would be the plan. Okay, so this is a review slide, so I don't even know if you have this, but remember we talked about, we kind of have a breaking point right here. These are the terrestrials, these are the gas giants, otherwise called Jovians. Okay. Jupiter, how long does it take it to make one rotation on its axis, according to this? Yep. Almost 10 hours, yep. Versus our 24 hours. And the reason that's so amazing is Jupiter's a lot bigger than us. So basically you get all this bulk going, twice as fast. What do you think about the surface temperature of Jupiter? Now remember, to get to Celsius, you subtract 273. So 125 minus 273, that'll give you your Celsius temperature. So you think it's cold or hot or pretty cold? 175 Kelvin. But it's hard to know where the surface begins because its surface is gas. What did it say? I like the video. I hadn't heard it put it that way. How do you know you're on the surface of Jupiter?
Something about the same atmosphere.
Yep. It's the same pressure as Earth. Yep. Just like we know, we talked about this the other day, as you go down in Earth's atmosphere, it gets more and more pressure. Okay. And so as you go down into a gas giant, it gets more and more pressure. So here about, this is gas and this is gas. Here about what we call one atmosphere. That's going to be the surface. Yep.
What did you say the temperature was again?
This says 125 Kelvin. That's the surface. So if you take 125 minus 273, you get what? let's see, 13, is that it? 6, 4, oops. Yeah, negative 48 degrees Celsius. Okay. So what do these all have in common? What are these? A nice picture. They're gas giants. Perfect. That was what I was after. Yep. And I think I might even said they kind of go in pairs. You can see the different color. I like this slide. It says a lot in the caption because it says that the reason that these, Jupiter, what's the name of this next one? Saturn, and then what we have?
Or Uranus.
Us 9. So Uranus, yep. And then Neptune. Yep, very good. Let's see if we can find it. Okay, ammonia goes right there. That's why they are that color. And then methane, that goes right there. That's why they're that color. I don't know if you can see it very good, but actually they all, can you see the banding here? Kind of like the bands? Like you see the bands here. But actually you can just barely see them here maybe. And these are also banded if you can see them. And they all, you can't tell it, but they all have rings and they all have a series of wings. So if you were to, the first thing on the surface of these planets, again, they're kind of sister planets, well actually all these, you would run into molecular hydrogen. What is the symbol for hydrogen? H. It's an H, yep. And most hydrogen here on Earth actually is what we say forms a molecule. It's diatomic. So molecular hydrogen looks like that, H2. Then with these two guys that are orange, you run into metallic hydrogen. Now what's happening as we go from the surface of these gas giants towards the core? What's happening to pressure? It's getting more and more, yes. So we're increasing pressure, and you're also increasing temperature. And one of the things about temperature-related pressure is if an increase in pressure by default will increase temperature. And you have other things going on there, but yeah. I like to kind of tease. Well, first off, metallic hydrogen. Does the blue planets have metallic hydrogen? No. But what's at the very core of these gas giants? It's like they swallowed a little terrestrial planet. I just think that is so cool. So this would be the greatest pressure and the hottest temperatures. Okay, but it's the pressure, you figure temperature would liquefy, but pressure is solidified. So that's kind of what they have going on there. Get in my tummy. I know there's a movie like that, right? Okay. Yes, Austin Powers. Get in my tummy. So OpenStax, I like how they do this. They have a lot of comparisons. Again, from left to right, we have the kind of pairs of planets. This altitude, why is this like, I'll go ahead and do a cross like this, altitude. What's negative 100 kilometers altitude? What does that mean? Like below sea level, exactly. And we just talked about this actually, this line marks where it's Earth's atmosphere. And the symbol for Earth is a circle with a plus, if you're looking for shorthand notations. So that's Earth's atmosphere. There's actually cool little symbols for all the planets, and it's on my bucket list of things to learn. Maybe we'll have to, but that's the symbol for Earth. Okay, so you can kind of see a little bit, these things are clouds. Literally, they're clouds. Now on Earth, let's see, how do I ask this in the form of a question? When you look up in Earth's sky and see a cloud, I'll just go ahead and let you, in case you don't know, but that is actually water in its liquid state. That's H2O, excuse me, liquid, okay? So what happens when it rains?
Releases water.
The liquid falls down, yeah. And actually, that seems right. So there are cycles, and we kind of saw them animated cycles on the videos a little bit. Now, unlike Mars, Mars is all real pictures. Some of what we saw on the little video we watched was just an artist's rendition of what they did, or what happened. So
does it rain on Mars?
Not that I know of. No, what? Yeah, Mars. It rains here. It rains here with these clouds, and it rains on Venus. Now, when I say rain, it's not necessarily water. I think it's sulfuric acid on Venus. On Mars, no, it does not rain. We have dust storms, but there's no, as far as I know, there's no liquid condensing in clouds on Mars. There is on Titan. Talk about that. This is talking about the winds. And I was looking at this because you see the wind's going positive and the wind's going negative. If you read the caption, like I did a few times, what OpenStax is saying is that if it's a positive wind, that means that the wind is moving in the same direction as rotation, faster than rotation in that direction. If it's a negative wind, that means it's moving opposite as its rotation. I don't know. This caption says that Saturn has the strongest winds, but I know that I'd have to double check. I heard it was Neptune has the strongest winds. So I don't know. It won't be on the test, but it's curious. Yeah, if I can't figure it out, it's not going to be on the test. Jupiter. So what's this little mark right here? Yes, that's the Great Red Spot. So Great Red Spot. And so if Jupiter rotates once every about 10 hours, you guys told me. Actually, the Great Spot kind of has a similar sort of pattern. And at the observatory, geeks who are running the telescopes will actually look online to see, it's called transiting. They'll see when the Great Red Spot is going to go in front so we can see it. So, now this thing, this actually, is it Europa? Europa, how many moons are there in the Galilean moons? 4, yeah, and one of them is Europa. So this is actually a moon now. It's, I think I might have said this the other day. This is actually, oh, this will work. See how my pen is casting a shadow? Okay, that's actually what's happening with that blemish right there. It's not the moon, it's basically the moon robbing the light to cast on the planet. So it's a shadow, in this case, a shadow of Europa. Well, that's kind of cool. One of the things that I was glad we watched that little video, did you see kind of the animation? This is a still image, obviously, but if we could take a video, you'd actually see, they're called belts and zones. You would see bands going this way, bands going this way. Bands going this way, and you would see swirling and all that too. So beautiful. So the video kind of talked about how big Jupiter is. It's very big. Okay. And I liked what the video said, and I don't have a slide to talk about this, but starting with Jupiter, the gas giants, their spacing is a lot different than the terrestrial planets. It's like way far away. In fact, I think the video said it's something like Jupiter was being offended or something to be so far from the sun, and then we step it out. One of the activities I've done with students before with regard to the planets is to kind of have them walk out the relative distances between the planets, and it's amazing. So when we start to talk about stars, actually we're going to see the thing about, if you have a nebula like made our solar system, okay, it's quite possible that that nebula can birth more than one star. It happens all the time. And it's kind of fun because then they're like kind of twins. So as it happens though, Jupiter maybe tried to get enough mass. The difference between a planet and a star is how much mass it has to go ahead and create what it's going to be. And this says that Jupiter would have had to have, in the solar nebula, it would have had to obtain 75 times more mass than it did to go ahead. Now, the reason for that kind of breaking point to go from a planet to a star basically is making enough, this is my gravity, making enough pressure and temperature in the core to go ahead and begin nuclear fusion. So Jupiter fell short, but it's still pretty big. We're going to talk about, hopefully we'll get in this unit of material, whatever we don't get to by the 16th, what I say here, yeah, that's the Monday before your test. We'll just have to swap on over to Unit 3. But a lot of times in astronomy, we look at what's called different wavelengths, different types of energy. And so this is looking at Jupiter in radio waves, just like the radio waves we use to communicate, okay, here on Earth. Here's a picture of this little Galileo probe falling through. It's an artist's rendition of what this little Galileo probe that was purposefully sent through Jupiter's clouds would look like. Now it was Cassini. Which planet did Cassini recently fall to its death? Saturn. Yep. I kind of thought about that when I saw this. So great red spot. And again, I really like the video because it kind of showed some animation with this.
How many Jupiters would fit in the sun?
That's a good question. I don't know volume-wise.
1,000. 1,000.
Is it 1,000? Did you?
I looked at it.
1,000 Jupiters volume-wise in our sun.
Yeah. That's just amazing. It's just, you don't think of the sun being really that big. I mean,
it's big, yeah.
It's huge.
And it's smaller than a lot of stars.
Right.
Okay, well, let's just pick up here on Friday. Thank you. Thank you.
So on homework, we need 2C, 2A, right?
Not 238 because we didn't get through. Yeah. Yeah, so just 2C. Yep.